We are going to start off by looking at the basic theories, the basic theorems in mathematics. So I'm going to basically divide all of my theory into 4 parts. Okay? I'm going to divide my theory into 4 parts. The 4 parts, and it's in your booklet, okay? It's nicely all summarized, but it would be nice maybe taking an A4 page, turn it sideways or something. And the 4 parts are pre-grade 11. Then there's going to be one big part divided into 3 subparts, which is for now the grade 11 work, which is about circles. People always ask me, but so why are you so good in maths? Is it just because you're smart? No. Because I know my theory and I've practiced a lot. Now, when I look at the pre-grade 11 parts, those are the part like straight lines, where I've got F, U, N, X, and T. Okay? Your three parallel line theorems and vertically opposite, and your angles on a straight line. That is grade 8 work. Then we move, okay, just one thing before I go further to the then part, to the moving on part. Remember, when working with parallel lines, you are not just allowed to say alternate angles or corresponding angles. You have to specify which sides are parallel. You have to. Also, make maybe a side note. Remember, there are only 3 ways of proving lines parallel. If I can prove the corresponding angles are equal, the co-interior angles are supplementary, or the alternate angles are equal, then the lines must be parallel. So if in the exam you see this random question, prove line AB parallel to KM, then I'll be looking to either prove an F, a U, or an N. I can't do it anywhere else. Okay, fantastic. Then when we're looking at triangles, with triangles, first of all, okay, let me not do that. The interior angles are supplementary. All of you guys are with me on that one? That's one of the axioms I talked about earlier. Then as well, if I have an isosceles triangle, then the opposite angles will be equal. Now here's just a nice side note you can make on your notes. This is the first way that I try to use when proving sides equal to each other. So if in an exam they ask me prove AB equal to BC, then that is the first thing I'll look at, is trying to prove the base angles equal. The second way that you can use is congruency. That's a second way you can use to prove sides equal to each other. Don't forget about congruency, please. It's not in the notes, but don't forget about it. 3 sides, side angle side, RHS, and angle angle side. Don't forget about it. They catch grade 11s and 12s out with it every year. Now, there is a third one that I would like you to put a nice little star next to it. Because you guys always forget about it. That the interior opposite angles, the sum of that is the exterior angle of the triangle. Don't forget about exterior angles of a triangle. Now, I just want to quickly say, I've always had my students struggle with, but so how do I know it's an exterior angle or not? Look at it as if it is a flag. And that is the little stick of the flag that you hold on to. You don't want the flag to look like that or to look like that. You want the stick to be straight. Remember that as well when we're working with cyclic quads. An exterior angle is always one where it looks like a flag, where the line goes straight on. Now, here's something that also you guys forget about. Go revise quadrilateral theorems. Revise all the properties, the definitions, because especially in analytical geometry, they love to say, oh, this thing is a kite. And then in the exam you've got to go, oh, what do I know about a kite again? So please go and make sure that you know your quadrilateral theorems as well. If you don't have it, please just go online, get it, or get an old grade 10 textbook and just photocopy those pages and make summaries for yourself. In grade 11, I have learned to divide my theorems into 3 parts. Okay? For a very good reason. So, what is your name? Yes. Say again? Diego. Okay. What are you going to study next year? Oh, I mean I'm thinking grade 12, sorry. In 2019, if all goes according to plan, what's your plans for studying? Electrical engineering. So you are going to be on that side of the campus. There by Steers, nothing Tribeca is there. Oh yes, we know that, okay. I know it because we always saw the engineers hanging around there. I was a math buff, and so I never saw those places. Okay? You're lying in front of the Ola. A beautiful building there. And you're chilling just before, class. And here comes this drop-dead, gorgeous lady. And she comes to you and goes, hey, Diego, my man, how are you? But for the life of you, you cannot remember who the heck she is. Are you going to start going, okay, who did I know again in nursery school? No, it's not in nursery school. What about primary school, right? No, wait, maybe it can be, no. Then high school. Are you going to go through all of those girls? No, what's your first thought going to be? Okay, you are a brave man, okay? Okay, you've lost a few brownie points there. Okay? Your first thought hopefully is, maybe she's in my class. Maybe she knows me from my class. And then if I can't remember them, maybe I go to grade 11 and 12, right? And then if I really don't know that, I go to maybe primary school, but I don't remember much about my primary school. Why am I asking you this silly question, Diego? So because you're trying to be funny, yes. Let me explain to you why. When you are put in that scenario, you don't go and look at all the girls you've known in your whole life. You go and try and open certain boxes and look, maybe she was here, maybe here, maybe here. Look, if I don't look in those few boxes, then I'll ask her. Okay? Why do you guys not do that in maths? When you guys work with circles, I've found the reason why kids struggle with circle geometry is they try and look at all 9 theorems every time they do a sum, and about halfway through you get so confused because there's all of these lines, and then you give up and you move on to the next question. Yes, some of you are going, that's me, sir. Yes, I know. It's my students as well. But please divide circle theorems into 3 parts. Centers of circles, cyclic quads, and tangents. Okay? When looking at centers of circles, what do I do first? Remember my house, I'm going to start at the foundation. I'm going to start by the definition. The definition of a circle gives me radii, and therefore I can look for isosceles triangles. That's step 1, definition. Step 2, I look at theorem 1, which says if I have a line from the center, if it's perpendicular to the chord, then it passes through the midpoint. And the converse, if it passes through the midpoint, it is perpendicular. Which kind of sums can I expect here? Pythagoras. Because for Pythagoras, I need a 90 degrees. Okay? I have seen this mostly with Pythagoras. But also, ladies and gents, that is the third way you could use to prove sides equal to each other. If I can prove I have a 90 degree there, then it must pass through the midpoint. The second theorem, that one's not good. I'm struggling with my circles today. The angle at the center is twice the angle at the circumference. Now, I encourage you to use your fingers, even though you might feel like an idiot. You'll be the idiot getting it right. From the center, form that angle, bring it together. From the center, form the angle, bring it together. Understand that there are 3 special cases of this one. The first one looks like that. Angle at the center is still twice angle at the circumference. The second special case looks like that. The angle at the center is twice angle at circumference. The third case, they love to catch guys out. Ooh, that's not nice. the angle at the center is twice angle at circumference. But it's always the one on the opposite circle segment. So, there. They love to ask these three in the test. Now again, I use my fingers because when there are 20 lines and 3 circles, it makes life easier. Theorem 3. If I have a diameter, the angle that subtends it must be a right angle. Okay? I want to quickly put it out there. For some of you guys, your teacher would not number the theorems this way. That's fine. This depends on the teacher, because this one is actually a corollary of this one, meaning a special case of this one. It doesn't matter. I break it up into 3 because it makes it easy, and then I remember everything. Theorem 4, 5, and 6 are my cyclic quad theorems. Theorem 4, I affectionately know this one. Oh man, why am I not getting this one right? Okay. That angle is that angle. That angle is that angle. I affectionately call it the bow tie, but you're not allowed to use a bow tie as your reason. It's angles in the same segment. Theorem 5. The opposite angles of a cyclic quad are supplementary. Theorem 6. The exterior angle of a cyclic quad is equal to the interior opposite angle. Again, a flag. Or the other way, however you are holding the flag, it must be a flag. Again, ladies and gentlemen, there are only 1, 2, 3 ways of proving something a cyclic quad. Don't freak out when they ask that of you. You've then got to prove one of these 3. Theorem 7, 8, 9 are my tangent theorems. Theorem 7. A radius is perpendicular to a tangent. Very important for grade 12 analytical. When I'm working with circles, if I can get the radius, the gradient of the radius, the gradient of the tangent, the product must be -1 because they are perpendicular to each other. Oh no, sir. Yes. This will go over to analytical geometry next year. All of these theorems. Theorem 8. Two tangents from the same point are equal. Very important. Look out for cyclic quads. I mean not cyclic quads, isosceles triangles. Okay? Also, for those of you bright sparks that's maybe seeing something here, what if I connect these 2 points to the midpoint? What do I have? I've got a kite. Okay? But please be careful, You are not allowed to just go, whoa, that thing is a kite. No, whoa. You must first state which sides are equal. And then go over and say, therefore it's a kite. And the wonderful thing is, now you can use all the properties of kites. Diagonals are perpendicular. The diagonals between the non-equal side is bisected. Okay? We love these kind of things. And ladies and gents, I just quickly want to say something. There's a 90 degrees there, right? There's a 90 degrees, right? Oh, but this thing's a cyclic quad. Because the opposite angles are supplementary. I love that, sure. So you are seeing all of these things. Some kind of magic. Okay? I know my theorems very well, that's the thing. And I've practiced a hell of a lot. Theorem 9 is most probably the most important tangent theorem. Theorem 9 says the angle that's formed between the tangent and the chord must be equal to the angle formed in the interior opposite circle segment. Now please, this is the second finger theorem. You follow the tangent, make the angle, bring it together. Follow the tangent, make the angle, bring it together. The same from this side. Make the angle, bring it together. So this one on this side is equal to that one. Okay, let's just do that so you guys don't get confused. This is the one that if you are strapped for time, you look for this. You look for this. Now, ladies and gents, it doesn't help if you just know your theorems. You've got to know, when do I look for these theorems? I look for theorem 1, 2, and 3. When they tell me there's a center of a circle. I look for theorem 7, 8, and 9. When they tell me I've got a tangent. Please be careful. I love it that about a few years ago, 3 years ago, in the matric final exam, they drew a line that looks like a tangent. Yes, and all my students win. Oh, they did it. It was a matric, it was grade 11 final. All of them assumed it was a tangent. The second question was, prove it's a tangent. Now you've already done the whole first part of the question. By assuming it's a tangent, you get to the second one and you go, now what? Now I've got to start everything over again because I assumed wrongfully that it is a tangent. So tangents you're not allowed to assume. But cyclic quads you are allowed to assume. Not allowed, you must assume it. And we're not going to tell you about it. So please be careful of missing these. Because we won't tell you beforehand, oh look, there's a cyclic quad. No, you have to look for it. And most of my students miss out on theorems because they forget about theorem 4, 5, 6. Not because they forget about theorem 7, 8, 9, because they forget about theorem 4, 5, 6. They forget to look for cyclic quads. Now, ladies